Okay, Assalamualaikum and good morning all. Okay, today we will learn about related rates. Okay, related rates regarding to the differentiation notes. Okay, this is the application of the differentiation syllabus. Alright, so we have strategy to solve the related rate problem. Okay, we have seven steps here, seven strategies. First, we have to rate the problem carefully. The second one is you have to draw a diagram if possible. The third one is introduce notation. Assign symbol to all quantities that are functions of time. Number four, we have express the given information and the required rate in terms of derivative. And number five, we have write an equation that relates the various quantities of the problem. If necessary, use the geometry of the situation to eliminate one of the variables by substitution. Then number six, we have to use the chain rule to differentiate both sides of the equation with respect to t, or we can use implicit differentiation for this step. Then number seven, we have to substitute the given information into the resulting equation and solve the unknown rate. Okay, so we have warning here. The substitution of the given numerical information should be done after the differentiation. Okay, after you complete all the differentiation given from the problem. Okay, after that we have to substitute the numerical information. Okay. Okay, now look at the example 1. We have the radius of a circle is increased at a rate 4 cm per second. How fast is the rate of the circle increasing when the radius is 20 cm? First of all, for the first step, what we have to do is we have to read the problem carefully and draw the diagram if possible. Number 2. Okay, this is diagram of the radius of the circle, and this is the curve. Okay, so step number 3, what we have to do is we have to introduce notation and assign symbols to all quantities that are function of time. Okay, assign symbol and assign symbols and abstract from the formula, from the problems. We have what? So now we have radius of the circle is increased at the rate of 4 cm per second. So we have rate here to mean that this is based on time. Based on time. Alright. So the radius of circle is increasing. So this is rate. So we have to abstract from the first sentence is dr. As usual, we have to assign r equal to radius of the circle. dr over dt equal to the given is 4 cm per second. 4 cm per second. Then we have how fast is the area of the circle increase. So the second sentence, we have to find the area of the circle increase. That means is the area of the circle increase, so meaning that this is the A area or of dt. So we have to assign A is the area of the circle. Right? Okay. So when the radius is 20 cm, so we know that the given from the problem is radius equal to 20 cm. Then they ask you to find dA over dt. So we complete for question for step number 3. So now look at to the step number 4. We have to express the given information and the required rate in terms of derivative. Alright, so we done this before. We done in the third step. Okay, then write an equation that related to the various quantities of the problem. So the equation or formula that uh, related to this problem is formula for area of the circle is 2 pi r square, right? So area of the circle equal to pi r square, right? Okay. So we have to, this is step number 5. Step number 5, then step number 4, then number 6. Okay, so we have to use the chain rule to differentiate both sides of the equation with respect to t. As I said before, step number 6 we can replace with the implicit differentiation with respect to t. Right? Oh, sorry. So now we get to the example. Okay, so we have to differentiate this equation or this formula with respect to t. Okay, so we have a equal to pi r square. So we have to differentiate with respect to t. So meaning that this is dA over dt equal to pi is the numbers or we call it constant. R is a variable of the radius. This is R. We have to differentiate R with respect to t. So recall back the knowledge or the basic idea of implicit differentiation. We can differentiate the different variable. Okay, let's say we R square. So differentiate, we get pi is remain. Then 2r, and then what is variable we differentiate now? So we have the r, right? Over the main idea is the main variable that we have to differentiate is dt, right? Okay, this is basic implicit differentiation. Okay, so we have dA over dt equal to pi 2r times dr over dt. Then we have pi here is a constant as usual. And then r given from the equation from the problem is 20 cm. Then this is step number 7. We have to substitute the information given. So we have 2 times 20 cm. Okay, then dr over dt. Okay, dr over dt is a given here 4 cm per second. Okay, the R over the T is 4 cm per second. Okay, then we can get 40 times 4, then we get 165 cm square per second. Alright, so look at to the equation here. Okay, the solution given from the notes. Okay, you can refer to this or you can refer to the my solution. Alright. Okay. So this is related rates. You have to look at to the problems, extract the information given from the problems or from the question. Then what we have to do is we have to find the equation related or formula related to the problem. And then what we have to do is we have to differentiate by using implicit differentiation of the problem. Alright. So as I upload before the class, I upload the related rates additional notes. Okay, you can find from the e-learning session for technical maths 2. So we have uh, different related rates from your workbook. Okay, so this is our additional notes for related rates. Okay, then we have additional exercises, related rates exercises. Okay, we have this. Right. So now look at to the example 1. Okay, related rates, additional notes. Okay, we have equation here. We have problems here, around 11 for problems. I set up the phone. Alright, so what is related rates problem? Okay, question number 1. Okay, the area of circle is decreasing at the rate of 2 cm per second, 2 cm square per minute. Okay, so the first sentence, what we have to do is, we have to abstract the first sentence. Okay, then we have area here, area of the circle as the previous exercise or previous example. But now we have the words of decreasing. So decreasing represent negative sign, yeah, negative sign. Okay, so the area is decreasing. The area of the circle is decreasing. So meaning that we have to abstract A is the area. Let A is the area of the circle. Alright. So we have dA over dt because of dt's rate actually decreasing equal to negative sign negative 2 cm square per minute. Alright. So this is information given from the first sentence. The second sentence, how fast is the radius of the circle changing when the area is 10 cm per second, 10 cm square. Right. So as the previous example, we have radius equal to something, right? But now we have to find dr over dt. Why? Because of we have to find the how fast the radius changing. The radius of the circle changing. So meaning that they ask you to find dr over dt. But the another information given is area equal to 100 cm square. Alright. So we have circle, area of the circle, formula of area equal to area of the circle equal to pi r square, right? So we have this. We have to differentiate this formula in terms of t with respect to t. So we have to differentiate a first. A equal to dA over dt. Differentiate pi r square. Then we have pi r square by 2r. Then we have dr over dt. We differentiate r variable. So we have to put dr here. And then our main variable is dt. So we have to put dt as a denominator. Okay. So the r given from the problems. R is not given from the problems. But we know that area is 100 cm square here. So from the equation A equal to pi r square, so you can find the radius of the circle, okay? So we have 100 here, pi r square. So r square equal to 100 over pi and r equal to 100 over pi square, right? Square root, alright, square root. Okay, calculate it now, then we get what? 100 divided by 5 square root answer, then we get 5.641. Then we get r equal to 5.642 in cm. Radius must be in cm. we can substitute this R into the implicit differentiation before. Then we have dA over dt equal to negative 2 cm square per minute equal to pi 2R. So you can substitute this equation or this. So as you know that I love to substitute the square root 1 and dr over dt equal to, we have to find dr over dt, right? Okay, now move element except dr over dt to the left hand side. So meaning that we have negative 2 over pi 2 square root 10, then we get to the 100, then we get 10 over square root pi, okay, equal to dr over dt. Okay, then we have equation. You can calculate it now. This is one, okay. So substitute and calculate it. We have 10 pi over square root pi. Then we have 17.725. This is R, so we have cm per minute. Okay, so we have this as a solution. So first of all, we have to extract the information given from the problem. The second one, we have to find the formula, okay, from formula related to the problem. Then we have to differentiate by using the implicit differentiation from the formula. Then we have to substitute all the information given from the differentiation, implicit differentiation resolve. Alright. Then the last one, we have the answer. So the R over dt equal to 70.725 cm per minute. Alright, the second problem, okay, regarding to the related rates is, okay, we have at certain instant, the length of rectangle is 16 meter and the width is 12 meter. The width is increasing at 3 meter per second. How fast is the length changing if the area of the rectangle is remaining constant? Okay, so we have more three information from this problem. Okay, so for the first sentence, we have this. First sentence, we have at the certain instant or the length of the rectangle is 16 meter and the width is 12 meter, right? So from this sentence, we can abstract the information is length equal to, this is length of rectangle, okay, then L is length, W is width of the rectangle, alright. So we know that from the equation, from the problems, given length equal to 16 meter and the width equal to 12 meter. Okay, this information we get it from first sentence. The second sentence, the width is increasing at 3 meter per second. The width is increasing at 3 meter per second. We have involved increasing sentence here, so meaning that this is rate of width. Okay, so we get dw over dt. Okay, the rate of width equal to 3 meter per second. Increase, so meaning that this is positive. Okay, so this is third information. equation. And the last sentence, how fast is the length changing if the area of the rectangle is remaining constant? So how fast is the length changing if the area of the rectangle is remaining constant? They ask you to find the length changing, meaning that you have to find dl over dt equal to 1, right? If the area of the rectangle is remaining constant, so meaning that our dA over dt, so meaning that the increasing or decreasing of the area is no value, remaining constant, 0. So dA over dt should be 0. Alright, so we have this information given from the 3 sentence in the problem 2. Then we know that rectangle is this figure, right? So this is rectangle. We have length and then we have width here. That area, okay, now we have to state that what is the formula for the area of the rectangle. So meaning A equal to L times W. This is area of rectangle. Okay, so we have to differentiate these two sides of the equation. First, we have to differentiate A in terms of D. Okay, so we have dA over dt. But now we have two different variables, L times W. So we have to use product rule for this particular question. Why? Because we have U and we have V in here. So if you assign U as equal to L, okay, L, I use the capital L before. Sorry. Equal to L, so this is L. Alright, so U prime equal to differentiate L is 1 times dl over dt. So you differentiate how the same way to differentiate using implicit differentiation. Alright, then you have V here, V equal to W and V prime equal to 1. You differentiate W over dt. Okay, so for U times V, so your formula for product rule is U prime V plus UV prime, right? Okay, so U prime V plus UV prime. So U prime equal to 1 times another variable. We have that variable dl over dt times V. V is W plus U. U is L times V prime. V prime is dW over dt. Right? So this is formula for differentiation of A formula. This is differentiation of A formula. So we know that from the formula, from the problems, the abstraction of the information from the problems, we know that dA over dt is the remaining constant equal to 0 and dl over dt is the item that we have to find. Then W we know that equal to 12 plus L equal to 16. Then dW over dt equal to 3, right? So we have to find dl over dt here. Okay, so move 16 times 3 to the left hand side. We get negative 48. This is 48. Move to the left hand side, then we get negative 48. Then we have dl over dt times 12, right? So we know that dl over dt, okay, equal to negative 48 over 12 equal to negative 4 cm. F or cm? Now look at the first meter, right? Okay. Okay, the third one is related to the ladder, the application of the real life. Okay, we have a top of a ladder, 5 meter long, rests against a vertical wall. If the base of the ladder is being pulled away from the base of the wall at rate 1/3 meter per second, how fast is the top of ladder slipping down the wall when it is 3 meter above the base of the wall? Alright, so we have one and two. We have two sentence from this particular problem. Right. Okay, first of all, look at to the first sentence. Okay, the top of ladder. So I recommend you to draw the ladder first. Okay, this is ladder. Sorry for the big, for the back drawing. Okay, for me. Okay, how what is long? How long of the ladder from the first sentence? 10 meter. Sorry, 5 meter. 5 meter long, 5 meter long. Alright. Against a vertical wall. So this is vertical wall, right? So this is wall. If the base of the ladder, okay, look at to the second sentence. So this is the long sentence, right? Of course. If the base of the ladder is pulled away from the base of the wall, if the base of ladder pulled away from the base of the base of the wall at rate 1/3 meter per second. So meaning that this rate will pull away from the base. Okay, so meaning that this is increased length. Okay, for example, this is length from the wall is 1/3 meter per second. So we can conclude that we have dl over dt equal to 1/3 meter per second. Then they ask you, how fast is the top of ladder slipping down the wall when it is 3 meter above of the wall? How fast the top, this is top of the ladder, slipping down to the wall, slipping down the wall to the base, So slipping down, so meaning that they ask you, for example, this is height. So they ask you to find dh over dt equal to what? If when it is 3 meter above the base on the wall. So they ask you from 3 meter above. So this h should be from 3 meter from the base. Okay. So we can find all of the information given and we can abstract and illustrate into the figures. Alright. Okay. So this is using this formula or this problem using trigonometric, but theorem Pythagoras. Okay, we use theorem Pythagoras to solve it. Okay, so now we have, okay, the hypotenuse equal to 5 meter, the height equal to 3 meter, but we don't have any information of L. But we can find from the theorem Pythagoras. So theorem Pythagoras says, Pythagoras theorem okay, state that we have C square equal to A square plus B square. So C is a hypotenuse. We can find from the figures, we can find is equal to 5 square equal to, okay, for example, we have as a length A, L squared plus the height square. Then height, then we can get height here. Height equal to 3 meter. 3 meter square. 3 meter square. 3 square. Okay, then we can find L here. So L equal to, okay, 25 minus 3 square, then we get 9. Okay, then we get 16 square root equal to 4, right? So L equal to 4 from this particular theorem Pythagoras. Okay, so they ask you to find dH over dt. So from theorem Pythagoras also we can find it, 5 cm, 5 meter square equal to length square plus height square, right? So this is theorem Pythagoras. Okay. Okay, we have to differentiate all of the variable in terms of p. So we have here, we have constant 25, okay, 25 meters. So we can differentiate 25 equal to 0. Then differentiate L square, we get 2L. Then we get dl over L, we use a capital, right? Okay, we have L square plus H square. So dl, we have sorry, 2L, L square differentiate, we get 2L, dl over dt. Plus differentiate H square, H square, then we get 2H, dH over dt. Alright, so now we have to substitute all information given from the problem. So 0, 2L, L given, L is 4, okay, then dl over dt is 1 over 3. Plus 2 times H, our H should be, okay, our H should be, okay, 3 meter. Then we have to find dH over dt. Okay, so move 2 times 4, 8 times 1 over 3, we can get negative 8 over 3 equal to 6 dH over dt. 6 move to the left hand side, then we get negative 8 over 3 times 6 equal to dH over dt. So actually this is 4, this is 3, 4 over 9. Then we get negative 4 over 9 meter per second. Okay. So this is answer for the changing of length if the base of the ladder, okay, slipping, pulled away from the base of the wall. Okay, so simple, but we have to use all 7 steps given from the beginning of the class. Alright, now we look at to the question number 4, the last example for today. Okay, how fast the volume of the rectangular box changing when the length is 6 cm, the width is 5 cm, and the depth is 4 cm. Okay, so we have a rectangular box like this, right? Okay, so we have length is 6 cm. Then we have the width is 5 cm and the depth is equal to 4 cm. Depth is here, the length is here, and the width is here. Right? Okay. So this is given information from here, length, width, and depth. Okay. How fast the volume of the rectangular box changing? So they ask you to find dV over dt, and of course V is the volume. Right? Yes, they ask you to find dV over dt. If the length and depth are both increasing at a rate 1 cm per second, length and depth are both increasing. Okay, so this is dl over dt equal to 1 cm per second. Okay, then we have d over dt equal to 1 cm per second. Okay, and width is decreasing at rate 2 cm per second. Then dw over dt equal to 2 cm per second. Right? So we have this dw over dt equal to 2 cm per second. Okay, so this is information given from the problems, and then this is a figure we can illustrate from the problems, right? So what is the volume formula for rectangular cube? V equal to length times width times depth, right? Or capital L times W times D. This is formula for volume of the rectangular. Okay, so if you look at this, we can find we have three function or three equations, three variables from the formula. We have to differentiate this equation. Okay, so the common one we have u times v, right? But now we have three different variables. First of all, we have to find the differentiation of this u times v first. Okay, we have to isolate v first. So we have to find u times v first. So u times v formula is, okay, for example, you have u equal to L and u prime equal to 1 dl over dt. So we have v equal to w and v prime equal to 1 dw over dt. Okay, we have u and u prime, v and v prime here, right? Okay, so to get this function, the differentiation of this function, we have to using u prime v plus u v prime product rule. So u prime v dl over dt, v is w plus, okay, dl over dt times w, then plus u is L, and v prime is dw over dt. Okay, this is the information given from here. Okay, differentiation of L times w. So please rewrite again this results to this column. Okay, we get w dl over dt. I put w in front of dl over dt plus L dw over dt. Okay, this is one function times with v, right? So now, this is u times v, right? U times v. U times v. So now, we can conclude that this is U. Again, we have used product rule times V. Right? Okay, so now our U should be U equal to W dL over dt plus L dW over dt, right? To differentiate this U, we have used 2 times product rule. Why? Because this is one function times one function. This is one function times one function. Alright, so U prime equal to, we have U prime V plus U V prime for the first function plus U prime V plus U V prime. Okay, is V1, V1. Alright. Okay, this refer to this refer to this. Okay, so U prime for this is U W, differentiate of W, then we get 1 times dW over dt, right, for U prime. Okay, so U prime times V. V for this is dL over dt plus uv prime. So u for first equation is W, and v prime differentiate 1, we get the 0. This is 1 dl over dt. So differentiate 1, we have the 0. So this is for the first equation plus u prime L, differentiate L, we get L1 dl over dt. Okay, plus u, what is your u? L, and v prime differentiate 1 dw, 1 is a 0. Okay, then this is actually is a 0. So look at the hold on, dw, u prime. Okay, u prime, this is v, so I forgot to dw over dt, put dw over dt. U prime v plus u v prime. U prime, this is u prime times v plus u v prime, right? So look at this. This is 1 times dw over dt times dl over dt, okay, plus 0. So this is same with this. 1 times dl over dt times dw over dt. So these two variables is the same, Okay, then we get 2 dw over dt times dl over dt. Okay, this is u prime. Then we have v here. So v equal to d, and your v prime should be 1 dt over dt, right? Okay, so put in the formula u prime v plus u v prime. So u prime equal to 2 dw over dt times dl over dt is your u. U prime v, what is your v now? Is d plus u v prime. So your u should be w dl over dt plus l dw over dt. This is your u times v prime, then times dt over dt. Okay, this is formula. Okay, this is formula after we differentiate dv over dt. Okay, so now we have to substitute all the information given from the beginning of the step. Okay, so we know that J equal to W equal to 5, L equal to 6, T equal to 4. Then we have dl over dt equal to 1, dv over dt equal to 1, and dw equal to 8. sorry, this negative and because of this leading. Negative 2 cm per second. Okay. Alright, so now we have to substitute all the information into the formula. We have to find the volume. So we have 2 dW over dt equal to negative 2 cm per second. Negative 2 cm per second. We don't put cm or put millimeter. At the end of the result, we can put the C. And then dl over dt equal to 1 and d equal to 4, right? This is 1, this is 4, plus W, the width equal to 5 cm. 5 cm. The L dot over W equal to 1 plus L equal to 6 times dW over dt equal to negative 2. dt over dt equal to, put here in the bracket and times this one. So that we can get negative 4 times 4, negative 16. 5 minus 12, then we get negative 7. Then we get negative 23 cm cubed per second. So this is your final answer. Okay. Okay, look at to these exercises. We have 7 total numbers of exercises here. So you have to solve all of the exercises. Okay, then please submit next week Monday. I repeat, next week Monday before 12 p.m. Before 12 p.m. I repeat, these exercises, 7 exercises, you have to submit before 12 p.m. Monday, next Monday, yeah, next Monday. Today is Wednesday. You have to submit Monday. Okay. Okay. Any question regarding to the related list, you can email me or you can meet me at the office. Okay. Thank you, class. So that's all for today. Thank you.